Hello. So today we're going to be looking at a more difficult exam question. Now this question I pulled out from an Extension 1 paper, but if you're doing just the Advanced Maths course, I still think it's a good idea to have a look at this example because it does cover many of the concepts that we learn in the Advanced Maths course. So let's make a start. So the first part is find f of -1. So all this question is, what this part is saying is just substitute in x equals to -1 and what do I get? So subbing in, and I get -1 all over 2. So that part of the question would be worth 1 mark. Okay, awesome. Part 2. Show that fx is odd. Okay, so if you remember back to the definition of an odd function, in an exam, what I would do is I would sort of write out what I need to prove here. So I need to show that f of -x equals to negative fx. That's what I want to prove. Okay, so in the question, I'll start off with f of -x. What is that equal to? Well, that's equal to replacing all the x values in the function with -x. So that'll be -x all over -x squared plus 1. And that's equivalent to -x all over x squared plus 1. Now, once I've got my answer to the simplest form I can, I look at it and I compare it to the original function. You'll notice that it's almost the same. The only difference is that there's a negative in front of the x. So that's actually what I want to see, because then I can say that that is equal to negative fx. So what I've shown is that f of -x is equal to negative fx, which means that the function is therefore odd, which is what I've required to show. Should put therefore, yep, therefore odd. Too many dots. Okay, so that part is also worth 1 mark. Part 3. Do part 3 maybe up here. So part 3 says, find x such that fx equals 0. So all this question is asking me to do is to replace fx with 0. So I'll write the function out again. And I just need to substitute 0 into fx and solve for x. Okay. Now, this might look like a hard equation to solve, but if you just multiply both sides by x squared plus 1, what's going to happen is that if you multiply the left-hand side, the 0, with x squared plus 1, you're going to get 0. And then if you multiply the right-hand side with x squared plus 1, you're just going to get x. So what that means is x is 0 when fx is 0. So that is your solution. It's just basically solving an equation. And that is worth 1 mark as well. Okay, part 4. State the domain and range. Now this will be worth 2 marks. 1 for the domain and 1 for the range. So the domain... how are we going to figure that out? Well, the domain is all the possible x values that the function can take. So let me just write out the function out here again, and we'll talk about how we're going to deduce what the domain is. So here we go. So what possible x values can the function take? Well, whenever you ask that question, it's probably a good idea to ask yourself which values it can't take. So if I think about it, can x be any positive number? Yes, because you can put in any positive number. There's no problems. Can it be any negative number? Yeah, it can also be any negative number. Could it be 0? Yeah, sure. Why not? If it's 0, yeah, f0 will be 0, so that's fine. Okay. Now, a lot of people would probably be looking at the denominator, which is a good idea, because that's when you could possibly have some sort of restriction. Now we know that the denominator can't be 0, right? So you're thinking, okay, is there an x value that makes this 0? Because if there is, that x value wouldn't work. Well, if I try to solve that equation, when is x squared plus 1 0? I'm going to get this. X squared equals to negative 1. Now, we know that this actually has no solution, because if you take the square root of both sides, you're going to get plus minus square root of negative 1, and that has no solution in the real number system. So, what that tells us is that there's actually no restriction on x in terms of having that issue with the denominator. So the domain will be all real x. Okay, now for the range. The range, how are we going to figure out the range? Okay, now this is not an easy question by any means, because you really have to think about what values can fx possibly be, given that you can put in any x, right? Now, a lot of people will probably jump to the conclusion that, oh, if I can put in any x, then y could be possibly anything as well. Well, the answer to that is no, it actually can't, because of the configuration of this function. If I put in a very large number, let's say 9999999, well, what's going to happen to fx? It's going to be very small. Could fx ever be that big? Could it ever become like 9,000, for example? Looking at it, it doesn't look like it can. But we're not sure, like, what's the highest value can be. So a lot of questions that we have to ask ourselves. Now, here's something that I do in an exam. Whenever I'm asked to find the range, and I'm sort of stuck on it, I actually skip the question and go straight to the next part, which is generally sketching it. Now, this might seem a bit counterintuitive, because generally you want to have the range before you sketch, but it actually is a more sort of easier to visualize kind of method, where if you sketch the function before you look at the range. And that also, you can also check to see if the domain is correct. So let's have a go at that and see what happens. So what I'll do is I'll do it over here. So write the function out again. Now, the trick to sketching this function is to look at what we've done. So we didn't do all of these previous parts for nothing. They were all building up to sketching the function. So firstly, I know that f of negative 1 is equal to negative a half. Okay, so I know this. So what I'll do is I'll write down all my information. F of negative 1 is equal to negative a half. I also know that the function is odd. And I know that x is 0 and when fx is 0, x is 0. Okay, so I know that x is equal to 0 when fx equals to 0. Okay, and I also did the domain, at least. Okay, so let's go through all these information. And see if we can put anything on our graph yet. So f of negative 1 equals to negative a half. What that means is, at x equals to negative 1, which is about here, the y value is negative a half, which is, let's say, here. So it passes through that point there. I'll do it in a different color so we can see. So that green point is a point on the graph. This piece of information, when x is 0, fx equals to 0, well, fx is simply just another way of writing y. So what this is saying is x equals 0 when y equals to 0. That is also a point on the graph, the origin actually, 0, 0. Okay, so if you actually had a look at the question, all they're actually saying here is actually find the x-intercept. That's another way to think about this question. Okay, because the x-intercept is when y equals to 0, and that's just another way of writing y equals to 0. Okay. Now, how does this information that fx is odd help us? Well, by definition, an odd function is point symmetrical. That means that if you rotate it 180 degrees, it should look exactly the same. So if I knew that this -1 and -1/2 is a point, then if I have 1 and I want to find what the y value is, it should be the exact opposite. So instead of being -1/2, it should be 1/2. So that should be 1/2. Now I can actually check that without having to know that it's an odd function by simply substituting in x equals to 1. Okay, so if I had considered f1, well, if you put 1 into the fx, you'll get 1 on 2. And that actually makes sense, right? So now I've got 3 points. Okay, so I know that it passes through those 3 points. It's not enough information for me to figure out what it looks like, but we've got one more trick up our sleeves. So the domain is all real x, so it can take on all real x, any x value. Let me see what happens as x gets very large. So we haven't studied the concept of limits yet, so what I'll do is I'll just write this. As x goes to infinity, what happens to fx? Okay, so I want you to think about this. If I put in a very large number into this function, what is fx going to be? Well, let's try that. Where's my calculator? Here it is. Let me just get it out. There we go. Oh, disappeared. Okay, so let's see my. Yep, I need my thing. Okay, yep. Okay. So, sorry about that. So what I'm going to do is sub in a very large positive number here. So that would be something like, say, 9999999. Put that in. And then I'm going to type in answer, because that saves my last answer, plus answer squared. Okay, so what do you think it's going to equal to before I press equals? Okay, so if you said something that's very small, close to 0, then you'd be correct. If you sub in a very large positive number, you're going to get something that's very close to 0, but still positive. The reason why is because this x squared is so powerful that it starts to eliminate, no matter what value you put in, eliminates the x value on the top. Because x squared grows so much faster than x. So the bigger the denominator gets, the smaller the function will be, right? Because if I had 1 on a billion, that's a very small number. Same thing here. If I put in a large number, the square of it is going to go up faster than just the x. So that's going to give me a very small positive number. Okay, so let's go back to our graph now. So what that tells us is as x goes to infinity, fx goes to 0. A good sort of like, this is more technical, but you put a little plus here to show that it's approaching 0 from the positive side. Okay, so what that means is the graph will end up somewhere here, right? It's going to approach 0, but in fact it will never reach 0. And what does that mean? It means that that line, y equals to 0, is actually an asymptote, right? Because that's the definition of asymptote. The curve approaches it at the extreme values. Okay, so I know that, and that's actually all I really need now, because if it's an odd function, it means that it must do the exact same thing on the other side, but sort of on the negative end, so the reverse. So it will actually approach 0 from the negative direction. So if you try subbing in x is negative infinity, so a very large negative number like minus 9999, you're going to get a very small negative number. It approaches 0 from the negative side. And so that's actually all I need to sketch this graph. Now, the only way that you can get these 3 points and ending up close to the x-axis is if the graph looks something like this. That is the only way. Okay? Because if it goes up to this point, it has to come back down to get there. It's not going to go up and then all the way back down like that. Okay? That does not happen. So again, and if this is an odd function, it needs to do the same on the other side, like that. Okay, because if you rotate this 180 degrees, it needs to look the same. And if you tried doing that, it will look the same. So that's my sketch. Now, don't forget you haven't done the range question, but now if you go back to do it, it actually isn't that hard, because we can see that the highest value that this graph will ever take is a half. Right? It's going to go down again, so it's not going to go up anymore. The lowest value you can take is negative a half. Now let's check that. Let's see what happens. So if I sub in something like very close to 1, let's say 1.00001, let me see if that still goes up. If it does, then our whole graph is wrong. If it doesn't, and it goes back down a bit, we're good. So let's have a look. So 1.0000. Now you don't need to put in this one. You can put in anything that's very close to 1. So something like this. Let's put the answer in, and hopefully it is less than a half. If it's less than a half, it means it's going down again, which is good, which is what we want. Oh, it is a half. Okay, so maybe I've put too many zeros. So let me put less zeros. Maybe this one. There we go. 0.49999, which is just under a half. So what that means is it's going down again, right? So at a half, that's where it's maxed out. Now it's coming back down. So that makes sense that this graph is correct, and the range is going to be negative a half, or y is between negative a half and a half. And now I've finished my previous question, so I'm going to get 2 marks for that, one here, one here. And then the graph, I'm not exactly sure how much it's worth, but I would probably say it's worth around 3 marks. And that is how you do this question here. Okay, this is not an easy question, but it's a very good question because it incorporates and combines all the concepts that we've learnt into one question. Okay, all right, that's it.